from Team 6 of COA Section 6. Today we are going to do the lab recording for the part 1B and part 1C. I'm gonna introduce myself. My name is Rafli, and this is my lab partner Hamza. And without further ado, we're gonna start the explaining
Cool.
for the code for the lab. Okay. For the lab 1 part B, we have the adding variable here. The the lab tells us to rebuild it and start without debugging, and also try to see what the output is. Here I have already done the lab. I have already done the code and stuff. So I'm gonna explain it line by line. Okay, so here we have the title. Title is add and subtract version 2. This program basically add and subtract 32-bit of unsigned integer and stores the sum in a variable. So first we need to include our library, which we are gonna use the Irvine 32 library for this one. And then we need to also include the data for the program to recognize which one is A, which one is B. Okay, so this data we input file 1 is D word. Basically, D word is the number of it's is the how is it the assigned lah. How you assign the bits. D word is 32 bits. For file 1 we have 10,000 H. File 2 we have 40,000 H. And then file 3 we have 20,000 H. Final file we still don't know what we are gonna get, so we simply just use the question mark. Okay, so here is for the code. We declare the main as like the process for the code that the computer needs to think about. So here we have file 1. We assign the EAX in the file 1 into the EAX. That's why we have the move. So basically we move the file 1 into the EAX. EAX now have the value of file 1, which is 10,000 H. And then the second command is to add EAX. So EAX gets added by file 2, and after you add everything, that is the new EAX value. So val 2 we know from the data is 40,000 H. So basically we use the first EAX, which is basically val 1, 10,000, and then you add it with the value from val 2, which is 40,000. So 10,000 added with 40,000. That's gonna be 50,000 H. And then we are gonna go and subtract EAX with val 3. So we have the new value from the add function here. Now the value of EAX is 50,000 currently. And now, since we are going to subtract it with the value of val 3, we're gonna do subtract 50,000 H. We subtract it with 20,000 H here. And then we have the final file. Final file, we don't have the value yet because we haven't specified anything on the data. But in the code, we are going to move the current EAX. So the EAX go through all these three codes first. And then you move the output of the EAX into the final file. You store the output here. And then you do call dump registration. It functions as to display the register, which is the final value of the EAX. And then you exit main end process and then end main. Now we're gonna see if the thing is correct or not. We gotta go to debug and then start without debugging. Here, as we can see, the last value for EAX is 0003 0000. So 30,000 H, 30,000 hexadecimal. Then we can conclude that the code is correct. And this is our final input. Sorry, final output.
Okay. Thank you,
Now
Dr.
I'm going to pass the lab 1C into my lab partner Hamza.
Yes. Now I will continue the final part of the lab 1, and it's part C. Lab 1 part C, I mean. As you can see right here, I do have the final code. The doctor told us yani, it will have the adding and subtracting 8 and 16-bit version of the code. You can copy it and paste it on the Microsoft Visual Studio. As you can see, I will explain it line by line. Firstly, we have the first 6 lines only for notes, title, and the description about this program and what does it do, the authors and date. And then after that, after all the notes, you're gonna include the library that you're gonna use inside of the code. After that, there's the data again. Now we will start storing the data inside the code. As you can see, value one is 1000 H, and the word is the description for how many bits. Word is for 8 bits actually. So the first value for the 8 bits is 1000 H, and the second value for 8 bits also is 4000 H. The third value for 8 bits is 2000 H. Okay, we don't know also the final value for the 8 bit, so you simply put a question mark. Secondly, you will do it for the 16 bits, as you can see. The val1 byte is used for the 16-bit version. So 10H is the first value for the 16-bit. Second value for the 16-bit is 40H. The third value for the byte is 20H. You don't know also the final value. We will find it later inside the code. And now we will solve the code that runs through the computer understand it. Main product. Okay, now we will move the value 1 to the AX, and we will start with 10,000 H, and then we will add a value 2 to the main value that is stored inside the AX. So 4000 H plus 10,000 H is about 5000 H. Then after that, we will subtract from the AX. The final value of the AX, the 50,000 H. We will subtract 20,000 from it, as you can see right here. We will subtract 20,000. Then we will move the final value to the AX. The final value of the three operations is stored inside the AX, so it's 30,000 H. This is for, then you call the dump registration. You will display all the registered values. Then this is for that one is for the 8-bit value, as you can see, and the second part now we can move it to the AH. It's used for the 16-bit. Move AH value 1, so the 1000H, as you can see, you will change it. You will change the value of the AH to 1000. Then you will add also the 4000 to the 1000, so it will be 5000. I mean, then you will subtract the value 3, the 20,000H. Okay, now you will display the final value of the three operations behind it. So it's 30,000H. Okay. Then you will call the dump registration again for the 16-bit version. After that, you will exit the code and then you will end the process and then you will end the main. After you see all of this, we're gonna compile without debugging because inside the lab, the doctor told us rebuild it and start without debugging. So we're gonna do exactly that. Now the code is compiling, yeah. As you can see, guys, the value for the EAX in the 8-bit is the 3000, and also for the 16-bit, it's also 3000 in hexadecimal value. Also, I didn't explain this part. I think this line you should write it because it clears every time you debug or run the code. It resets the value of EAX to 0, so it doesn't change the value of EAX place. It doesn't different make it different because if you run it every time without this line of code, it will change the location of the final value of EAX. So this code is very important actually. Okay, I think that's about it. Thank you guys for listening. This was Team 6 in the COA section 6. Thank you so much. Salam alaikum.